until now, what you have done is you have looked at frequency domain modeling. In this, you have looked at partial fraction expansion, Laplace transform, inverse Laplace transform. Okay. And then you've looked at time domain modeling. And of course, you have also done differential equations. Okay. So today what we are going to do is we are going to look at going from frequency domain to time domain, or time domain to frequency domain. Okay. So we'll take a look at an example and we'll discuss it in that context. This also reflects on your exam. I glanced over whoever submitted, and there is something very simple which many of you have not gotten. Not many of you, but some of you have not gotten. So for example, if you're given this, okay, 24. If you're given this is also equivalent to this block diagram, this simple block diagram, right? 24 over s cubed plus 9s square plus 26s plus 24, and you have a reference input or input here and the response or output on this side. These two are equivalent, okay? So the question here would be something like, for the above transfer function, find state space representation. Okay. A part of this question was in your exam as well, which was the initial 1 or 2, 1, 2. It was very, very simple. I don't know why you got it wrong. So if you look at this, the simple way to do it is, step 1 is, you cross multiply the this one. So you have s cube plus 9s square plus 26s plus 24 into C of s, okay, is equal to 24 R of s, right? Always recognize the system variables and output, input. Here, input is never a system variable, okay? So what is the input here, input signal, you would say? R of s is the input signal, okay? So if you were given, in this, if you're given, find a response for, find the step response of that system, 1 over s. So you substitute R of s is equal to 1 over s, okay? So step 1 is this, and you're going to convert this to an ordinary differential equation, okay? So we have discussed this many times. It's very, very simple. So what is the differential equation associated with this? It is simply, yeah. So it is, if I write it as C triple dot of t, right, plus 9 C double dot of t plus 26 C dot of t plus 24 C of t is equal to 24 R of t. Got it? For this, I don't think many of you have gotten this right in your exam. So this is a very, very simple thing. You shouldn't get this wrong. Okay? D cube, you could put it something like this as well. D. This is also okay. Right? This is the same thing. Your dot always represents a time derivative, right? Okay. So if you put this, that's it. Okay. Now you should be able to convert a differential equation to transfer function as well, very easily. And I think many of you have not done that either. Okay. So if you're given this, just looking at it, you should be able to tell what the transfer function is. Okay. If you practice it enough, it is really a piece of cake. You don't even have to think. Okay. Step 2. So what is the order of this differential equation? Third order differential equation, right? So what you're going to say is this state space representation. How many state variables? There will be 3 state variables because it is a third order. So your state variables, you can just say Z1 is equal to C of t, Z2 is equal to C dot of t, and Z3 is equal to C double dot of t. Okay. your state equations would be something like this. Z1 dot is equal to C dot of t, which is Z2. Z2 dot is equal to C double dot of t, which is equal to Z3. And Z3 dot is equal to C triple dot, which is equal to, so I'm going to extract this. It is 24 Z1 minus 24 Z1 minus 26 Z2 minus 9 Z3 plus 24 R of t. Okay. Right. So these are the state variables. These are the state equations. Okay. State variables. And these are state equations. So on the left hand side are state variables. On the right hand side, what are the right hand side? Huh? No, these. No. System variables. These are the system variables. These are the state variables. Okay. So you'll have a state equation for every state variable. Can you correlate? Z1 is this. You have a state variable for each state. You have a state equation for each state variable. Okay. So if I just so you can simply write Z1, Z2. So I don't even need to write this. You can just write cap Z dot. I'll write this. Z, just decorate it, and so what you have is 0, 1, 0, 0, 0, 1, minus 24, minus 26, minus 9, Z plus 0, 0, 1, R of t. Okay. So you see this, what that Z is, that cap Z, the decorated Z, it is just a state vector. Okay, so Z is this. You see that, right? So numbers Z2, if you write Z1, Z2, Z3, Z2 is 1, right? Z1 dot, so Z1 dot equal to 0, you have Z1, Z2, Z3, right? This is Z1, Z2, Z3. That Z is Z1, Z2, Z3. Z1, Z2, Z3. Z1 dot is what? Z2. How do you multiply? How do you multiply matrices? You multiply this row into this column. So your column is 1, Z1, Z2, Z3. Okay. If you want Z2 in this, because here it is Z1 dot, Z2 dot, Z3 dot. Huh? Oh yeah, you're right. So this is 24. This one? Negative 24. So if I don't write this, I will write this as Z1, Z2, Z3 dot. Now you get it, Sammy? Z1, Z2. Can you relate it now?
Clear.
Huh?
It's more clear. Yeah.
Okay.
I think that's the like, the how you most commonly see, and that's how you're getting.
Okay. So what you do is you just make it a habit of writing it something like this. Z dot, the capital Z equal to AZ plus BU. Okay. So this A is this Z is this, B is this, and this is this. Okay. And what is your output? So your output equation would be Y is equal to, right. See, so you just have to define this. What is this? C100, right? Because you have Z1, Z2, Z3. Okay. From this you can see here you can make out C of S is output, right? Because it's output over input. And what is C of S? C of S is essentially this. Sorry, this, right? Huh? This one? It's 1. Lowercase 1? Okay. Yeah, this one? This is the uppercase Y. Yeah. So this remains Y. Okay, it's actually you can take it as uppercase and lowercase because it just is one value. This will always be one value. Do you see it? It will not be a matrix. It will not be a column matrix. Right, it will be this plus this plus this. Right? It will be one value always. Why? So you can uppercase or lowercase would be the same. Here uppercase makes difference because this is a vector, right? You see it as a column matrix. Column matrix relating to here. So this is not, it will not be different outputs. It will be one output but a combination of system variables. It is, how do you define output? Output is a linear combination of system variables, right? That is how we define output. So if you see, it is a linear combination of system variables. Now again, see, keep in mind, this is a heads up. It's a very simple way to go from transfer function to state space. And there is one of these questions will be there for your midterm. Okay, don't lose points on these. You're not doing anything. You're just simply following some few steps to get to the answer. You're not really doing physics here, right? Not even mathematics actually. You're just following some steps. You can program this and always get, see this is what MATLAB will also give you. So if you were to look at MATLAB, remember we discussed this in the lab class. So what is the command here which we can use? TF2SS, right? So you have TF2SS. If you use this and you define the system, this system, sys or sys equal to some numerator over denominator, right? And then you just use that sys in this TF2SS. Okay. 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 The thing with state space is you can end up with different representations. It depends on how you define these variables. So if you define, let's say if you define Z1 as combination of this and this, and Z2 as this and this, something like that. If you do a combination, then you'll end up with a different state space. Right. So, but you can always try to use this to get one form of state space representation. Okay. But when you do it in hand, with regards to this will carry significant amount of points in your midterm. So don't try to understand and just follow the simple steps to get your points. Make sense? All right. Y is okay. If you look at this, if you look at the transfer function, what is transfer function? This is transfer function, right? So this is G of S. And how is it defined? Output over input. So what is the output? C of S. If C of S is the Laplace transform of the output, what is the inverse Laplace of C of S? C of t. So what is C of t? In terms of state variables, Z1. So you just want Z1, right? Z1 represents the C of t. This is C dot of t. This is C double dot of t. But your output is just C1 from this Z1. Sorry. So that is the reason you have 1, 0, 0. 1, 0, 0. So if you expand this, what are you going to get? Y is equal to Z1, right? Z1 plus 0, Z2 plus 0, Z3, right? Or it is just Z1, which is equal to C of t. If you are given a system like this, you will always get it like this. Okay? But if you are given, we'll take a look at another this thing. Which one? This one? This one? Yes, welcome. So look at Z1 dot. What is Z1 dot? See, you formed your state. All you're doing is you're forming your state equations and trying to write them in the form of a matrix, right? So Z1 dot is what? Z2, right? You want Z2. If you split this open, you want it again in this form. Got it? So now there is another example. This is also easy. You just need to follow steps. This will be slightly different. Dion, this will answer your question. So if you have something like this, okay. So you'll be given, so what is the difference between these two? That has a constant numerator. This has, the numerator here is a polynomial. Okay. So here it will change a little bit. So what you need to do is, as step 1, so question again would be, find state space representation. If you get something like this, it will carry more points. And you can definitely score all those points. It will carry significantly more points. Okay. So your step 1, you split these into 2 systems or 2 cascade systems. This is how you do it. We have 1 over s cube plus 9s square plus 26 plus 24. And then you have okay. So you have x1 of s over r of s is 1 over okay. What you have done is you have just split the numerator as a second system. So here, we'll learn this later, but cascade means you can just multiply whatever is there. So if you multiply, you're going to multiply, how do you multiply these? You're going to just multiply x1 of s, g of s is equal to x1 of s over r of s into c of s over x1 of s. Okay. And this just cancels out. So you still end up with this. Okay. You haven't changed anything. That's what I'm trying to convey. So we've just split it open in this form. You see it? This is just a representation. It's a block diagram representation. See, the thing with something like this is it depends on how you develop it, how the mathematics is, what that representation means. Mathematics is inherent in nature. This is according to laws of nature. So x1 will be this. Right. So if you look at this system, x1 is the input, C of s is the output. For this system, R of s is input, x1 of s is output. Right. Okay. This is a cascade system. Okay. So you first do this. If you develop the, so this is step 1. Step 2, you'll do the state space development for the system. Okay. So it will be almost this, only that 24 R of t will not be there. Okay. So your z would be again simply 0 z dot 1 0 0 0 1. And then you have minus 24 minus 26 minus 9 and z plus 0 0 1 x. Okay. So we have developed it for only this. So 24 is, this numerator was 24, remember? So that is the reason we got 24. Okay. So you can say this is actually for first system. Okay. And for second block, we have step 3. Okay. So you can say y of, so what you can say here is C of s is equal to a square plus 7s plus 2 into x1 of s. Okay. And this would be so C of t, so C of s would be equal to s square, C of t would be equal to x1 double dot of t plus 7 x1 dot of t plus 2 x1 of t. Okay. this is Z3 plus 7 Z2 plus 2 Z1. Okay. So Y would be 2, 7, 1 Z1 Z2 negative 2, 7. I don't think so. Huh? So you have Z1, Z2, Z2, right? You see the correlation. Remember the correlation. I shouldn't have erased this, but what did we say? Z1 was x1 of t, right? Z2 is x2 of t, and Z3 is x3 of t. Sorry. X1 tar of t. Okay. Got it? So this is when you get, and this will be different. Okay. Right. This is for this is the state equation. This is the output equation. So you're actually this whole system. So you have this, right? What is our general state space representation is Z dot is equal to AZ. I hope you are not confused when I use X and Z interchangeably, right? It's okay. Okay. So here Z, this is your Z dot. So Z dot is equal to, your A matrix is this 0, 1, 0, 0, 1, minus 24, minus 26. If you practice just a few problems, you can actually just look at something like this and figure out what the state space representation should be, right? It's very very intuitive. If you just, for example, now you can relate this, right? You can relate this one and this one, right? You'll always get something in this row because you can see these minus, minus, minus. That's what you're going to always get. Okay. Huh? They are always negative. Yeah. So if you, for example, they are not always. If one of this is negative, it will be positive. Yeah. This one? This one? No, this one is, we don't have the 24 anymore here, right? We got, this is our system. So if this was 24, for example, if it was, then we would have split it as 24 and that. Okay? So if you are given something like this, don't panic. Just split it such that you get it right. This has to be always the input. So you have to get that input in there. Okay? Did you, were you guys successful with, you said you tried, anybody else tried the state space, the transfer function to state space? I forgot to give you the code. Okay. So, it is exercise 3.1? Okay. Experiment 3.1. That was for last lab. So this lab, we're going to do 4, but I don't think you're prepared for 4. Okay. See, this is what we'll do. I think it will have an advantage on your course. Try to do, its poles and zeros are very easy. Poles and zeros are essentially, for example, the poles and zeros for this. Right. The roots of the denominator are poles. The roots of the numerator are zeros. Got it? So roots of this would be poles and roots of that would be denominator. Do that for tomorrow. It'll not be easy. It'll not be difficult. Okay? Right. I want the pre-lab for experiment 3.1. I think that will tell me how, if you're understanding it or not. Lab report you can turn in once I give you the code. Fair enough? Yeah. Or if you have done it already, then you can turn in the lab report as well.
So you want us to figure out the poles and zeros for how would happen?
It's fairly simple. It's just roots of